world of science, discoveries are made that can completely alter our vision of the future. What seemed distant and impossible just yesterday is slowly but surely becoming part of reality today. Deep within the laboratories and experimental setups, a new era is forming, almost imperceptible, yet already noticeable by the shadows it casts on our familiar concepts of energy. One project after another, one country after another, and now, on the horizon, a technology is emerging that could change everything, from our homes to flights to other planets. It has no loud advertising campaigns. It develops quietly through highly precise measurements and immense pressure. But those who are watching its progress know, what's coming isn't just a technological leap. We are on the brink of an energy revolution. What is this source? Where does it draw its power from? And why are the leading world powers investing billions in it? The answer is very close now. Subscribe and like so you don't miss the most interesting. We are on the verge of incredible discoveries. On December 13th, 2022, scientists from the Lawrence Livermore National Laboratory reported a breakthrough in the field of nuclear fusion. For the first time, the reaction produced more energy than was used to initiate it. This achievement came after more than 7 decades of research. The discovery gives hope for obtaining an environmentally clean source of energy, one that is not tied to fossil fuels or radioactive waste. To achieve the result, on December 5th, the National Ignition Facility used 192 lasers directed at a small cylinder containing hydrogen inside a diamond shell. The laser beams simultaneously irradiated it from the top and bottom, vaporizing the material and generating X-rays that hit a deuterium-tritium sphere inside. In a fraction of a trillionth of a second, the fuel absorbed 2.05 megajoules of energy and released 3 megajoules in the form of neutrons. More energy was produced than what was input. This marked the first instance of exceeding the ignition threshold, when fusion begins to yield energy. Construction of the facility began in 1997 and was completed in 2009, with an investment of $3.5 billion. The first modest results were obtained in 2014, when the energy produced was equivalent to what a light bulb consumes over several minutes. The breakthrough came in 2021, when the reaction first produced nearly 3/4 of the energy that was put into it. Despite the success, the technology is still far from commercial application. As Laboratory Director Kimberly Budil noted, it will take decades. But now it is not a matter of 50 or 60 years, as was previously believed. If the necessary efforts and resources are invested, a full-fledged power plant could be built in the foreseeable future. What other important breakthroughs have scientists made on the path to controlled nuclear fusion? And how close are we to creating an artificial sun on Earth? What prevents us from turning record temperatures into a stable energy source? And what technical barriers still need to be overcome? On January 20th, 2025, the Chinese fusion reactor East set a new record. It successfully maintained plasma for 1,066 seconds at a temperature of around 100 million degrees Celsius. This is nearly 3 times longer than the previous record set in April 2023, when plasma was sustained for 403 seconds. The temperature remained the same, 6.6 times higher than the core temperature of the Sun. The record was made possible after another upgrade to the reactor located in Hefei, Anhui Province, China. This achievement demonstrates the steady progress of the project toward one of its main goals, increasing the duration of stable operation at extremely high temperatures. This is especially important, considering that initiating nuclear fusion on Earth requires a temperature higher than that of the Sun. Inside the star, this is facilitated by the immense pressure created by gravity. On Earth, it is impossible to replicate such conditions, so compensation is needed through temperature. The achieved 100 million degrees Celsius is still not sufficient to initiate a sustainable fusion reaction. Furthermore, all previous experiments by Chinese researchers involved heating electron plasma. To start full nuclear fusion, the ion component of the plasma must also be heated to comparable levels, but no information has been provided regarding progress in this area. The new result from EAST is significant. It helps to refine technologies, test material durability, and develop methods for working with plasma, bringing humanity closer to creating a stable and safe source of fusion energy. Which project has proposed a more cost-effective fusion reactor, and what are its prospects? Is it possible that an unconventional magnet inside the chamber will change the future of nuclear energy faster than tokamaks? A New Zealand startup, OpenStar, has introduced an experimental nuclear reactor in which they managed to sustain a plasma cloud at a temperature of about 300,000 degrees Celsius for 20 seconds. The company's founder, Ratu Mataira, explained that the team achieved these results in just 2 years of work with a budget of under $10 million. Instead of the traditional design with external magnets, the reactor uses a levitating magnet placed inside the chamber. According to them, this architecture is more scalable and easier to modify compared to classic tokamaks. The development has attracted the attention of experts from the Massachusetts Institute of Technology, who have noted its high potential. To continue their work and move to the commercial stage, OpenStar plans to raise up to $1 billion in investment in the first quarter of 2025. Could humanity abandon fossil fuels if nuclear fusion becomes a reality? What is preventing the launch of a perpetual energy source on an industrial scale today? Nuclear fusion is considered a promising method for generating electricity due to a number of key features. Its primary product is helium-4, a harmless inert gas, and tritium, which also forms during the process, can be used as fuel. The reaction only requires deuterium, tritium, and lithium, elements that are available on Earth. Deuterium can be extracted from water, lithium is abundant in the Earth's crust, and tritium can be produced within the reactor itself. Such plants do not emit greenhouse gases, carbon monoxide, or particulate pollutants, unlike fossil fuel-based power stations. Additionally, nuclear fusion reactors are much safer than nuclear fission reactors. Fusion is not a chain reaction, and in the event of reactor damage, there is no meltdown because the process requires continuous external support. Under Earth conditions, the fuel for fusion is not capable of causing an explosion. It is insufficient for that purpose, and the reaction stops if the supply is interrupted. However, there are significant challenges. Although the fusion process itself does not produce radioactive waste, the neutrons generated in the process gradually make the reactor's shielding materials radioactive. To reduce this effect, special radiation-resistant alloys are used, but they are significantly more expensive than conventional materials. There is also a risk of radioactive tritium leaking into the environment. Although its radioactivity decreases over time, the half-life is 12 years. Moreover, at the current stage, the technology is still far from being widely implemented. It is unlikely that practical fusion power plants will appear before the mid-21st century, as there are many unresolved technical challenges and society remains cautious about the potential risks. Nuclear fusion energy not only opens new horizons for our planet, but could also radically change approaches to space exploration. Imagine a journey to Mars, which would have previously taken months, now possible in just a few weeks. This would be made possible by the creation of fusion engines capable of providing the necessary thrust for interplanetary travel. But even more amazing is that the coming years could be crucial for realizing these ideas. With each passing day, technologies are becoming more accessible, and investments in fusion power plants are gaining momentum. In the next decade, we may witness the first commercial reactors, which will forever change the energy sector and offer humanity new opportunities. Stay tuned for new discoveries and technological breakthroughs. Subscribe to the channel to stay up to date with the latest news and learn how nuclear fusion energy will transform not only our world, but also our perspective on the future of space exploration.